All right, so these are the class notes for swirl dipping. So find a place where you keep your notes and add swirl dipping to it. This is going to be a cool project that we do, but it also has applications to mixtures. So this fits really nicely in our unit 2 here, okay? So swirl dipping, what it is a painting technique, that has been used for hundreds of years. That has been used for hundreds of years to create beautifully decorated end pages for books. A painting technique that has been used for hundreds of years to create beautifully decorated end pages for books. So if you've ever opened a really, really old book, sometimes the inside of the front cover and the first page have really pretty swirls of color on them. And those were made via swirl dipping, okay? So you can still use it for paper, but today it is mainly used for painting guitars. Now, if you look on the internet for swirl dipping demonstrations, you're going to find it used for a lot of other things too. I've found videos that they use swirl dipping to kind of marble paint the interior of a car. You can do it for cell phone cases. There's lots of different ways that you can use swirl dipping. You just have to have the right kind of paints that will actually stick to the object that you're painting, okay? So it is mainly used for guitars today. We will be swirl dipping, we will be swirl dipping wood objects, either blocks or little wood ornaments in our class. Okay, so now we're going to go through the chemistry of swirl dipping. Now that we know what swirl dipping is. Okay. Swirl dipping, okay, this is creating a type of heterogeneous mixture. So we have created a homogeneous mixture by making an alloy in our penny alloy lab. Now we're going to create a heterogeneous mixture. This is heterogeneous because you will be able to see the different colors of paint. On your finished product. Okay. If you can see differences, then you know it is not homogeneous. Because remember, homogeneous means uniform. So if it's not uniform, if it's not the same all the way through, then you've created a heterogeneous mixture. Okay. All right. How does it work? Well, we are going to use two properties of the paint. We are going to use two properties of the paint to do this project. First, number one, oil paints are hydrophobic. Oil paints are hydrophobic. Now, as a reminder as to what hydrophobic means, literally that word means afraid of water, okay? But oil paints don't have feelings, so they're not really afraid of water. What we're going to say instead is that oil paints do not mix well with water. Okay, and that's really because of what their base is. An oil paint is mostly oil that has pigments in it to make it a color, okay? And so oil paints, oil doesn't mix well with water. It's hydrophobic. So oil paints won't mix well with water, makes them hydrophobic, okay? The second property of oil paints that we're gonna rely on is that they have low density, okay? Oil paints have low density. Okay. Because their density is lower than water's, they will float on the surface of water. Okay, so you've got oil spills happening in the ocean sometimes, and that slick of oil is floating on top of the water. That's because oil has a lower density than water. Or if you look at a salad dressing that has separated into the oil and the vinegar layer, okay, the oil is on the top because oil has a lower density than the vinegar, which is mostly water, okay? Well, oil paints have a really low density as well because they're based in oil. They float on top of the water, and that's going to allow us to do the procedure that we're going to get or use to get this nice swirl effect in our painting technique, okay? Okay, so I'm gonna just go through the steps in general, and then we'll be actually doing a project like this, okay? So we will float paints on water. I'm gonna float some paint on some water, swirl the paint, dip our wooden objects into the bucket, for lack of a better word. Okay, so we're gonna have a bucket with water, paint floating on top. We're gonna dip our objects into the bucket. Decant, okay, this is another word that we haven't seen in a little while. We're going to decant the paint, okay, which means remove the paint from the surface of the water. Anytime you remove a top layer, even if you're just scooting it to the side, that's decanting, okay? And that's what we're gonna do. We're gonna move the paint away from the center and then pull the painted object through the clean water. Okay, so we've got our object dipping it through the paint layer that's floating on top of the water. Then we decant that paint away, so we have clean water, and you pull your object out and it'll have a nice swirled effect. You're gonna see this in the next assignment, okay? So pull the block or the object through the clean water, hang it to dry. That is the general procedure that we're gonna use to do some swirl dipping in our class next week. Right, or next class period, depending on what year we're talking about here, okay? So those are our swirl dipping notes. You're gonna need to refer back to these when you do your swirl dipping project in order to answer some questions to follow up with that project. But also refer back to these when we do our Unit 2 exam, because we're talking about a couple of things. First of all, making a heterogeneous mixture, but also within that process, we have some properties like hydrophobia, low density, and separation techniques such as decanting. So definitely keep these notes somewhere handy, and thank you. I will see you guys in class.